Welcome everyone, this is Vineet from Edureka. In today's session we are going to go through MapReduce tutorial. The agenda for today's session is, we'll understand what is Hadoop MapReduce, we'll understand what is MapReduce in a nutshell, we'll explore the two major advantages of MapReduce, we'll understand Hadoop MapReduce approach using an example, we'll understand how MapReduce works with Yarn and its components, we'll understand the application workflow of Yarn, we'll understand how to execute a MapReduce program. Okay, so I hope you guys are clear with the agenda of today's session. Guys, can you give me a quick confirmation on the chat window so that I can move ahead? Thanks Matthew, thanks Andrea, thanks Saurav, thanks Shubham, thank you guys. I hope everyone else is also clear. Andrea is asking a question, that is, are we going to do practical? Yes, we are going to do practical in today's session. However, we'll not go into very depth of MapReduce. That is something we'll be exploring in the next session. Okay, but we'll understand MapReduce conceptually in very depth. Great. So let's move on and start with the very first slide, which you have already seen in your previous sessions, that is on Hadoop components. As you guys already know about the two main components of Hadoop, the first one, that is Hadoop storage, which is handled by Hadoop HDFS, which you have already gone through in your previous session. In case you would like to revise it, you can always go through the recording present in your LMS. In today's session, we are going to focus on the processing unit of Hadoop, that is called Hadoop MapReduce. So guys, let's not wait. We'll move on to the very first slide on Hadoop MapReduce, that is, what is Hadoop MapReduce and why is it required? Does any one of you have the idea what is MapReduce? Would like to give a try? Can you please write down on the chat window? Anyone? No worries. Let me tell you. So Hadoop MapReduce is actually the processing unit of Hadoop, using which you can process the big data that is present on Hadoop HDFS or that is stored on Hadoop HDFS. But what is the requirement? Why do we need Hadoop MapReduce in the first place? It is because the big data that is stored on Hadoop HDFS is not stored in a traditional fashion. The data gets divided into chunks of data which is stored in respective data nodes. Okay, so there is no complete data that is present in one single location or one centralized location. Hence, a native client application which used to be there, like a Java application or any other application, cannot process that data right away. And hence we needed a special framework that has the capability of processing the data that stays as a blocks of data into respective data nodes, and the processing can go there and process that data and then only bring back the result. So that kind of a framework is Hadoop MapReduce. Guys, are you clear with this? Because this is very important concept. You need to understand why do we need Hadoop MapReduce in the first place. If you can give me a quick confirmation on the chat window, we'll move ahead. Saurav is very clear. What about the others? Andrea, Matthews, Sam, guys, are you clear? Ashish? Okay. Looks like most of you are clear. In case you have any queries, you can write down on the chat window itself. And we'll move on to the next slide and we'll see MapReduce in a nutshell. So this particular slide basically gives you the overview of MapReduce and what are the things that are related to MapReduce. To start with, what are the applications of MapReduce or where it is used? For example, it is used for indexing and searching. It is used to create classifiers. It can be used to create recommendation engines, like it has been created by big e-commerce companies like Amazon, Flipkart. It can be used for analytics by several companies. When we talk about the features of MapReduce, it is a programming model. It can be used for large-scale distributed model like Hadoop HDFS. It has the capability of parallel programming, which makes it very useful. When I talk about functions that are present in MapReduce, there are basically two functions that get executed. One is the map function and the second is the reduce function, which we'll be understanding in detail in today's session as well as in the subsequent session after this. If you talk about design patterns that has already been there in the industry for a long time, yes, you can also implement all those design patterns using MapReduce, like summarization, classification, recommendation, or analytics, right? Like join and selection. MapReduce has been implemented by major giants like Google, and it has also been adopted by Apache Hadoop for HDFS, for processing data in HDFS, for processing data using Pig, for processing data using Hive, or for storing data or executing queries over the big data using HBase, which is a NoSQL database, right? So this is something which actually gives you the overview of MapReduce and what are the various features, what are the applications where it is implemented, what are the functions that are used. That kind of information is given in this slide. Guys, are you able to grab that information? If you can give me a quick confirmation on the chat window, that would be great. Okay, Matthew says yes. What about the others? Everyone, are you clear? Andrea, is it clear to you? Saurav says yes. Ashish says yes. Thank you. Anyone else? Okay, let's move on. And now we'll explore the two biggest advantages of MapReduce. The very first advantage is parallel processing. You must be aware of parallel processing from before as well, because it's not a very new term. Using MapReduce, you can always process your data in parallel. Okay, as you can see in the diagram, there are 5 slave machines and there's some data that is residing on these machines. These boxes are nothing but representing a chunk of data, a block of data or a HDFS block, which is getting processed in the respective slave machines, right? You can see a circle going on. So this simply represents the processing. Okay, so in here data gets processed parallelly using Hadoop MapReduce, and hence the processing becomes fast. So it is as simple as the work time problem that you would have solved in your school days. For example, you would have solved a problem like, if a particular task is done by one person, he is going to take 1 day. So the same task, if it is done by 3 persons, how many days it is going to take to finish the job, right? So what are we doing there? We are actually distributing the task among 3 people, and hence the time that is taken to execute that job becomes less, right? Similarly, same happens in Hadoop MapReduce. What happens is entire chunk of data gets divided by Hadoop HDFS into HDFS blocks, and the processing now processes this data in parallel, and hence the processing becomes fast. So guys, are you clear how MapReduce does parallel processing and how is it faster than the normal processing? Everyone, if you can give me a quick confirmation. Saurav says yes. Saurav is able to understand everything. Great. So Matthew has a question. MapReduce uses Yarn framework. Absolutely right, Matthew. Yarn was introduced with Hadoop 2.0 and hence it uses Yarn framework, which we'll be talking later in the session. Okay? Is it clear? Andrea, are you clear with this? Thanks for the confirmation. Thank you. So I'll move on to the next slide and we'll explore the second advantage of Hadoop MapReduce, that is data locality. This is one versatile thing that is given by Hadoop MapReduce, that is, you are able to process the data where it is. What does it mean? Let me tell you. In your HDFS tutorial session, you understood that the data that you move into Hadoop cluster gets divided into HDFS blocks, and these blocks are stored in the slave machines or the data nodes, right? As you can see, the data is stored in all these slave machines that are there in this picture, right? What MapReduce does is it sends the processing, it sends the logic to the respective slave nodes or the respective data nodes where the data is actually residing as HDFS blocks. So what happens is the processing is executed over a smaller chunk of data in multiple locations in parallel, right? This saves a lot of time, as well as it saves the network bandwidth that is required to move big data from one location to other. Just remember that this was big data which was broken down into chunks, right? If you start moving that big data through your network channels into a centralized machine and then process it, it will give you no advantage, right? Because you're going to consume the entire bandwidth just in moving the data to a centralized server, right? So using MapReduce, you are not just doing parallel processing. However, you're also moving the processing, the logic that you would like to execute over big data into the respective slave nodes where the chunks of data are present, and hence you're also saving a lot of network bandwidth, right? Which is very beneficial. Finally, when the slave machines are done with the processing of the data that is stored at the slave machines, they send back the results to the master machine. Because the results are not as big as the blocks that were stored on the slave machine, hence it will not be utilizing a lot of bandwidth, right? So what they do is they send the results back to the master machine. These results are aggregated together and the final result is sent back to the client machine, which actually submitted the job, right? So are you guys clear with data locality? That MapReduce is processing the data at the location where the data is stored instead of bringing the data into one centralized server. Guys, if you can give me a quick confirmation in the chat window, that will really help. Everyone? Saurav says yes. Matthew says yes. Guys, if you have any question, you can write down on the chat window. Before we move to the next slide, we have a question from Matthew, which is, who decides which processing part should be sent to which data node? That is actually a very good question. So what happens is, client submits the job to the resource manager. Okay, so the resource manager is the one which tells that, okay, you need to execute the job on these respective data nodes where the data is residing. Okay, it decides on the basis of nearest data nodes that are there, so that a lot of network bandwidth is not utilized. Okay, does that answer your query, Matthew? Great, thanks, Matthew. Saurav says master equal to name node. Saurav, what happens is, yes, name node is the master, but it is the master of the SDFS part. When we talk about the processing of the big data part, that is handled by resource manager. Hence, resource manager is the master of that unit. Is that clear? Great, thank you. So we'll move on to the next slide and we'll explore the traditional versus the MapReduce way. For this, we'll take a real life analogy of election votes counting. Okay, everyone would be aware of elections, right? It happens everywhere. So you would be aware of booths as well. So booths are the location where people come and cast their votes, right? So there are n number of booths spread across the country, right? Let's take a scenario where we have 5 booths, okay, where people will go and cast their votes. Now, we also have a result center which has all the information of the booths that are there and where they are located. Okay. However, when people come and cast their votes in these respective booths, the votes are kept there itself. That is, booth A will have its own n number of votes, booth B will have n number of votes, booth C will have n number of votes. Similarly, booth D and E will also have n number of votes that were casted there itself. That information is not shared with the result center, right? So let's move on and let's see how does the vote counting will happen in the traditional fashion. Okay. So if you solve this problem using the traditional way, all these votes will be moved to a centralized result center right here, and then the counting would start. Now in this case, if we do this, what happens is we need to move all the votes to a result center, which is a costly affair, right? That is, you'll have to gather all the votes and move to a center location. So there is a cost involved along with that, along with the effort, right? Second point is result center also gets overburdened because it has to count all the votes that were casted in these respective booths, right? As well as, since they are counting votes that were casted in all the booths, it is going to take a long time. So this process doesn't work very well. Let's see how does MapReduce solve this problem. So the very first thing is MapReduce doesn't follow this approach. Now when you see the MapReduce way, what happens is, as you already learned in our previous slide, that is, MapReduce follows data locality, right? So that means it is not going to bring all the votes into a centralized result center. Instead, it will do the counting in the respective booths itself in parallel, right? So what is happening is, so once the votes that are casted on every booth are counted, they are sent back to the result center, and the result center now only has to aggregate the results that were sent from respective booths and announce the winner. So this way declaring the result becomes easy and very quick. So guys, did you understand the difference between the traditional way and the MapReduce way? Can you please give me a quick confirmation on the chat window? Were you able to understand the advantages of MapReduce way that we talked about, that is parallel processing as well as data locality? So Matthew says, so you want to say that instead of moving data to processing, we move processing to data. Absolutely right. That is what I explained in data locality. And again, this example that we are talking about shows the same thing. That is, instead of counting at the result center, we are counting in the respective booths itself, because the number of votes that are there in respective booths are less, and the same task can be done parallelly in all the other booths as well. So you are sending the processing, you are applying the logic in the respective booths itself, and you are only sending the result back to the result center. Are you clear, Matthew? Good. Anyone else who has a question here? Otherwise, I'll move on to the next slide. Okay, let's move on. Now let's understand MapReduce in detail. Okay. Now what did we do in the previous example? So we had an input, okay, and that input was distributed among various booths. Now every input was processed by a respective map function. Okay, in the starting I told you that MapReduce has got two functions, one is map and the other is reduce. So the counting part that I talked about, which was done on the respective booths, was done by the map function. So every input at every booth was counted using the map function right here. After that, the results were sent to the reduce function. So the aggregation part is done by the reduce function and the final result is given as the output. So this is what has happened in our previous example. Okay, so the entire thing can be divided into map task and reduce task. Map task gets an input, the output of the map task is given to the reduce task, and this reduce task gives the output finally to the client. Are you guys clear now? If not, let's not worry, let's move on to the next slide where you'll understand this better. Okay, in this slide we'll understand the anatomy of MapReduce. So what happens is a MapReduce task works on a key value pair, as you can see on the left. So when I talk about a map takes the input as key value, okay, and gives an output as a list of key value. Okay, now this list of key value goes through a shuffle phase and an input of key and a list of values given to the reducer. Finally, the reducer gives you a list of key value pairs. Okay, in this slide, what you need to understand is MapReduce works with key values itself, and the remaining thing we'll be understanding this in the coming slides. So guys, are you clear with this? A map task takes an input as key value pair, gives the output as list of key values. In between map and reduce, there is a shuffling phase which happens and gives input as key and a list of values, and the final outcome is list of key values. Are you clear with this? Matthew says okay, he's not very convinced. However, I'm sure Matthew, you're going to understand it better in the next slide. What about Saurav? Are you clear? Andrea, thanks for the confirmation. We'll move on to the next slide. Now let us take an example to understand the MapReduce way. Okay, so we had an input, right? The input that you have gets divided or it gets splitted into various inputs, okay? So that process is called input splitting. So the entire input gets divided into splits of data on the basis of the new line character. The very first line is the first input, that is deer, beer and river. The second line is the second input, car, and river. Okay. Guys, can any one of you tell me what is the third input split? Quickly on the chat window, very simple question. What will be the third input split? Absolutely right, Andrea. It would be deer, car and beer. Absolutely right, Matthew. Ashish says the same thing. It would be deer, car and beer. Correct. Now let's move on to the next phase. That is the mapping phase. Now in the mapping phase, if you can see, what we do is we create a list of key value pairs. Okay. So the input is key and value. So key is nothing but the offset of the line number. The line number is the key and the entire line is the value. Okay, so line 1, the offset would be the key and the value would be deer, beer and river. In real life, the line number or the offset is actually a hexadecimal number. However, to make it easy, we will only consider it as 1 or 2, right? So line number 1 would be the key and the entire line would be value. Okay. When it is passed to the mapping function, what mapping function will do is it will create the list of key value pairs. For example, deer. So what it will do is it will read every word from the line and it will mark 1 after the comma. Okay, it will mark 1 as a value. So deer comma 1, beer comma 1 and river comma 1. Why are we putting 1 after every word? It is because deer is 1 count, so deer comma 1. Beer in itself is 1 count, so beer comma 1. River in itself is again a 1 count, so river comma 1. So we have key value pairs, that is deer comma 1, beer comma 1 and river comma 1. Similarly, when we come to the second line, we'll read each word from the line, that is car, and we'll mark 1 against it because it is 1 count in itself. So car comma 1, again car comma 1 and again river comma 1. Finally, can you guys tell me what will happen with the third line? What will be the result of the mapping function when this is the input? Can you please write down on the chat window? So by the way, this is a word count process. We are trying to count the frequency of every word that is there in the input file, and that is why we are following this input file. Okay. Matthew says it's deer 1, car 1 and beer 1. Absolutely right, Matthew. It is exactly the same. That is deer 1. Deer is in itself 1. Car in itself is 1. And bear in itself is 1. So Matthew has an excellent question, that is, why can't we write car, comma 2 in the second line? He's talking about the second map function. Okay. He says, why did we write car, comma 1 and car, comma 1 right here and not car, comma 2? So Matthew, it's actually very logical. That is, why can't we aggregate if it is there in the same map phase itself? So yes, you can do that. However, there's a concept called combiner that I have not explained it to you right now, which we'll be talking later in the sessions. Okay. So for now, it will be kept like this. Aggregation is not going to happen in the map phase. Are you clear? Good. Let's move on and let's go on to the shuffling phase. So let's see what happens in shuffling phase. In shuffling phase, for every key, there is a list prepared. Okay, so K2 comma list V2. For every key, there is a list of values that will be prepared in shuffling phase. So what shuffling phase will do is, so it will find the appearance of key bear and it will add the values into the list. So let's see what is happening. You can see that there are two incoming arrows. The first arrow is coming from list 1, so bear, and then in the list it has added 1. The other arrow was coming from this list, so bear, comma 1 again. So what it did, instead of adding another key, it just added the value 1 in the list of values part. Okay, so the result would be bear, comma list 1, comma 1, because there were two occurrences of bear in two different lists. Guys, are you clear? Can you give me a quick confirmation? Matthew says yes. Saurav, are you clear? Good. Similarly, when I talk about car, so again for car, another list will be prepared for values. So as you can see that there are three incoming arrows. Two arrows are coming from the same list, so car 1, comma 1, and the third arrow is coming from the last list, again comma 1. Okay, so since there were three occurrences of car, hence the list of values will have three ones, 1, comma 1, comma 1. Okay, similarly goes with deer. Now deer was there in the first list and the third list, hence there were two occurrences, so deer, comma 1 and 1. 1 and 1 is nothing but the values that are against the respective keys in the map phase, right? So guys, if you're clear with this, can you tell me what will be the fourth answer? Okay, Matthew says river 1, comma 1. Saurav also says river 1, comma 1. Same answer is given by Andrea, Sam, Ashish. So a lot of people has given me the same answer. So absolutely right, the answer would be river 1, comma 1. It is because river was found in two different lists. The first list, river 1, so first occurrence, and then river 2. So river and then the list of values, that is 1, comma 1. Now comes the reducing phase. In reducing phase, what we are doing is we start aggregation of the values that were present in the list against every key. So for bear, there were two values present in the list 1, comma 1. So the summation of these values will be done. So bear, comma 2. Similarly for car, the values will be summed. So 1 plus 1 plus 1 becomes 3. A result from reducing function would be car 3. For deer, it becomes 1 plus 1, deer 2. Can you tell me what will be the last answer? Saurav says river, comma 2. Matthew agrees with him and says river, comma 2, and so does everyone else. Absolutely right. The answer would be river, comma 2. It's because the values are 1 and 1 and 1 plus 1 becomes 2. So this will be the result for river. And at last, the final result will be sent back to the client with bear, comma 2, car, comma 3, deer, comma 2, and river, comma 2. This is how the entire word count process works when you are using MapReduce way. Guys, are you clear with this? Guys, if you are able to understand this MapReduce example, you will be able to work with MapReduce very easily. So guys, please tell me if you are clear with this or not. In case you have any queries, please ask me now so that I can clear your doubts. Matthew says he's fine, he's clear. Good. I request everyone to give me a confirmation on this particular slide if they are clear or not. Saurav says yes, he's clear. Andrea says cool, good. Ashish says he's clear. Sam says he's clear. Okay. Thank you everyone for the confirmation. We'll move on to the next slide. Now let's execute this program practically. Okay. I showed you the entire process. Now let's execute this program, execute a word count program over the same input file that we saw and see what is the result. Okay. Are you guys excited about this? Give me a confirmation in the chat. Saurav says, yep. Matthew says yes. Good. Let me take you to the practical part now. So I'll enter the password. This is the Edureka virtual machine that you can download from your LMS. I'm sure that the setup is already ready on your end. In case you're not ready with the setup, guys, please do that. Okay. So this is the input file that I have already created to save time. So this was the input in the example, right? Deer, bear, river, car, river, deer, car, bear. Okay. So what we are trying to do is execute a word count program over this. For your information, let me tell you that. So there are a set of MapReduce example that already comes with the Hadoop package that you download. Okay. So let me just show you. Even word count example is also a part of it. So I'll just take you there. My Hadoop is installed in user lib Hadoop. Let us see the contents of this folder. The MapReduce examples jar is present in the share folder. I'll just change the directory share Hadoop, and we need to go to the MapReduce part. We'll find the jar in this. This is the jar that I'm talking about, that is Hadoop MapReduce examples jar. Let me show you the examples that are present in this jar first. So Hadoop jar, Hadoop MapReduce examples 2.2.0.jar. So I'll execute this command. It will give me the list of all the classes, all the examples that are there within this jar. As you can see, one is aggregate word count, aggregate word list, BBP, along with a description. So you guys can go through it and try all the examples. What we are going to try is the word count example, a MapReduce program that counts the words in the input files. Okay, so this is what we are going to execute now. You can try other examples as well. As you have already seen the list of examples that is present in the Hadoop examples jar, now it's time we execute the word count example. But before that, we need to move the input file to HDFS first, and then only we can execute the MapReduce example. It is because MapReduce takes the input from the HDFS and dumps the output to the HDFS. Okay. So very first thing is I'll move the file. So Hadoop DFS, that is Hadoop distributed file system, hyphen put, that is I'm trying to put a file into HDFS. I'll give the path of my file that is present on my local file system, that is home, Edureka, desktop, and then the name of the file input, and then I'll give the HDFS directory, that is I would like to store on the root directory of HDFS. Okay, I'll press enter. I'm sure by now you would be very clear with the HDFS commands. In case you are not, I request you to please execute the HDFS commands that are present in the HDFS tutorial blog, or you also have a document in the LMS. Okay, so looks like a file has been copied to HDFS folder. Let me just check if it has been done. So Hadoop DFS, I'll directly cat, that is I'll read the file directly, and I'll put the name of the file, that is input. So I'm telling that go look for the file input that is present in the root directory of HDFS and read it. Okay, so this was the file that we copied, right? Good. So let's execute the word count example. I'll write Hadoop jar, and I'll mention the name of the jar, that is Hadoop MapReduce examples jar. I'll mention the class that I want to execute, that is word count. I'll give the input part of HDFS, that is \input, and then I'll mention the output directory, that is first example out, and I'll press enter. So looks like it has started the execution. It is again connecting to resource manager. It is because the client submits the job to the resource manager, right? Good. As you can see, the map and reduce task has started now. First, the map task would be executed. You can also track the status of your job at this particular location. Okay. So for every job, there's an ID, application ID that is generated. So you can always go to port 8088, which is nothing but resource manager's port. Now, as you can see, the map has finished 100%, and finally the reduce phase would be executed. So reduce phase is also complete now. Now finally the job has executed successfully. Okay, as you can see, completed successfully. Let's go and check the output. Okay, I'll clear the screen. So Hadoop DFS -ls, and the name of the directory was first example out. and enter. As you can see, there is a success file that has been created and a part file. The output is always present in the part files. Okay. So we'll just read the part file now. Instead of ls, now I'll use the command cat, and I'll copy this part and I'll paste at the end of first example output. Okay. And let's press enter. This is the command that I'm using to read the final part file, the output. So this is the output: beer 2, car 3, deer 2 and river 2. Let's try and compare this with the input file itself. So first we'll read the input file, Hadoop dfs -cat \input, right? Saurav says success file is used to display the status. Absolutely right, Saurav. So this is the input file, and now we'll read the output file again, the part file. Now guys, can you compare? Is the result correct? Let's check. Beer, it says it has come twice. So beer 1 and then beer 2, right? Car has come thrice. So car 1, 2 and 3. Deer has come twice. So deer 1 and then second. Finally river came twice. So river 1 and river 2. So we can see that the output that has been given by the word count example is absolutely correct. So guys, are you clear how to use the inbuilt examples that are there with Hadoop and execute a MapReduce program using the command line? If you're clear, please give me a confirmation on the chat window. Matthew says yes, Saurav says yes. What about the others? Good, thanks everyone. Now, do you want me to execute the same word count example on a bigger file? Will that be interesting? Good. Let me just show you. So for that, what I'll do is, let's open the browser first. Let's select a website like Apache Hadoop itself. Okay. So let's open Apache Hadoop. Apache Hadoop. So we'll open this website. So as you can see, there are multiple tags and multiple words there. Let me open the source file of this page. So I'll go to view page source. So how about running the MapReduce program on this page source and find out the frequency of every word that is coming in this page? Will that be something you would like to see? Good. So what I've done is I've written a small Python script. Okay, I'll just show you. Using that Python script, I'm trying to scrape the page that we have just opened, that is Apache Hadoop org. Okay, so I'll just change my directory to desktop first. I'll clear the screen. So the name of the script is scrape.py. Since it is a Python script, its extension is scrape.py. I'll open the file scrape.py. So in this, just I'm telling that this is where my Python is located. I'm importing a library that is called URL lib2. The page that I would like to scrape is http hadoop.apache.org that I've already shown you now. Using this command, that is URL lib2.url open Hadoop page, I'm able to fetch the entire source code of this page in one variable that is called page, and then finally I'm writing this page variable, the content of this page variable, in a file that is called Hadoop Apache. Okay, that will be created on the desktop. Okay, very simple script. I'll just save the file and I'll execute the script by /scrape.py. So you'll see that there will be a file that will get created once this script is finished. So right here, as you can see, Hadoop Apache is the file that has been created. I can open it for you. So it has the entire source code that was there in the Apache's website, right? Interesting. Now what I'll do is I'll execute the same word count example, but before that I need to move the file into Hadoop HDFS, right? I hope you remember. So I'll do Hadoop DFS -put. I'll give the path of this file, that is Hadoop Apache, the local path, and then I'll mention /, that is I would like to move this file to the root directory of Hadoop. Okay, I'll make the terminal full screen now. Now the file has been copied. Now I'll execute the word count example on this. So Hadoop jar, I need to give the entire path where my jar is located, that is user lib Hadoop, within that share folder Hadoop MapReduce, and then there will be the Hadoop MapReduce example jar. Next, I need to mention the class I would like to execute, that is word count. Now I'll mention the name of the input file that is present on HDFS, that is Hadoop Apache, and I'll give the name of the output directory where I would like to store the final result of this MapReduce program, and I'll name it as second example out. Okay, and let's press enter. As you can see, it's connecting to resource manager again. It is because it is somebody who executes all your jobs that are submitted from the client. So the MapReduce task has started now, as you can see. Which will be the first phase that will get executed, guys? Can you tell me? Okay, Saurav says map. Matthew, is it reduce phase which will be executed first? Matthew says no, it will be map. Okay. What about Andrea? What do you think? Is it map or reduce? Correct. It will be map itself. I hope everyone is very clear that map will get executed first. So as you can see, map has executed now. Even the reduce phase is also over, as you can see. And we have the results written on HDFS. I'll clear the screen. So let's check the results quickly. So Hadoop DFS -ls, the output directory was second example out. And we'll find the part files within it, which will have the final output. So as you can see, this is the part file. Let's try and cat it. Okay, so Hadoop DFS -cat. I need to mention the entire path. I'll copy this and paste and enter. It will be a huge file. It is because the number of words that were present in the file was more than the previous input that we gave, right? As you can see, for every character, every word that was there in the file, you have the word count, right? So let me just clear this. So let's try and find out the count for Hadoop. Okay, so I'll simply execute a Linux command, that is grep Hadoop. On the output that will be received from after reading the file, I'll simply look for the word Hadoop. So Hadoop came into so many words, as you can see right here. So this is the command that I executed, and here is the result. Okay. So since this was the source code, it is a little messy. However, when you're working with real data set, you'll be cleaning that data set first, and then only you'll be executing your final processing. Okay. Even for cleaning, you'll be writing a MapReduce program. Okay. So how did you like the example? Matthew already says that, wow, that's a great example to observe. It gives the taste of real-time scenario. Okay, so Matthew, it was not a very real-time thing. However, still we were able to scrape a page and then do a word count on this. Okay, there are a lot of other things that can be done using MapReduce because the limits of MapReduce is endless. Okay, let's go back to our slides now. Now let's understand how MapReduce is using Yarn to execute the jobs over the cluster. But before we go ahead, guys, do you know the full form of Yarn? What does Yarn stand for? Quick, guys. Andrea says yet another resource negotiator. Absolutely right. It is the one which allocates the resources for various jobs that needs to be executed over the Hadoop cluster. It was introduced in Hadoop 2.0 itself. Till Hadoop 1.0, MapReduce was the only framework or only processing unit that can execute over the Hadoop cluster. However, in Hadoop 2.0, Yarn was introduced, using which we were able to go beyond MapReduce as well, as you can see in this slide. Okay, so we have HDFS in the bottom. In between, we have got Yarn, and using Yarn, a lot of frameworks are able to connect and utilize HDFS. Okay, so now even MapReduce has to connect using Yarn request for resources, and then only it can execute the job over HDFS, that is Hadoop cluster. Okay, similarly, Spark can connect, other search engines can connect to HDFS, Storm can connect to it, HBase, which is a NoSQL database, which can connect to it. So the applications of HDFS became huge just because Yarn was able to open the gates for other frameworks, other big data analytics tools as well. So guys, are you clear where Yarn falls into the picture? Matthew says, what is the difference between MRV1 and MRV2? So MRV1 was essentially the part of Hadoop Framework 1. With Hadoop 2, Yarn came in the picture, as well as MapReduce was upgraded to MRv2 with several changes in the classes. The classes were updated. However, the syntax of writing the MapReduce program remained the same. But in this scenario, MapReduce now connects with Yarn to access the HDFS. Are you clear? Matthew? Matthew says resource manager and node manager also came into the picture. Absolutely right. Along with Yarn, resource manager and node manager also are the new daemons that was introduced into the Hadoop cluster. Previously, it was the job tracker and the task tracker. However, they were removed in 2.0 Hadoop, and resource manager and node manager were introduced along with Yarn into the Hadoop framework. Okay, let's move on. Let's talk about the daemons present in Hadoop 2.x cluster, which runs the components, that is storage and processing. In the HDFS tutorial class, we understood the daemons, that is name node and data node, in detail. In today's session, let's understand how does resource manager and node manager works in Hadoop 2.x cluster and manages the processing and the jobs that needs to be executed over the Hadoop cluster. Okay. So what is resource manager? Resource manager is the master daemon that runs on the master machine, which is a high-end machine. Node manager, on the other hand, is the daemon that runs on the slave machines or the data nodes, okay, along with the data node process, right? Let's understand this in a little more detail and explore other components as well, okay? So what is a client? A client is nothing but which submits a MapReduce job, like we did from the CLI, okay, that is command line interface. So it is also a client using which we were able to submit the MapReduce job, okay, so it is a client. Similarly, a client could be a Java application or anything. Now, what is a resource manager? Resource manager, as I said, is the master daemon to which all the jobs are submitted from the client. It is the one which allocates all the cluster level resources for executing a particular job. Resource manager runs on a machine which is actually a high-end machine with good configuration, because it is the master machine which has to manage everything over the cluster. Okay. What is node manager? Node manager is a slave daemon that runs on the slave machines or the data nodes. So every slave machine will have a node manager running. It monitors the resources of a particular data node. Resource manager manages the cluster resources and node manager manages the data node resources. Okay. So what is job history server? It is someone who keeps a track of all the jobs that has been executed over the cluster or has been submitted on the cluster. It keeps the track of their status as well. Okay. It also keeps the log files of every execution happened over the Hadoop cluster. Okay. So what is application master? Application master is again a process that is executed on a node machine, on a slave machine, and created by a resource manager to execute and manage a job. It is the one which negotiates the resources from the resource manager and finally coordinates with the node manager to execute the task. Okay. Similarly, what is a container? A container is created by the node manager itself, which has been allocated by resource manager, and within the container all the jobs are finally executed. Okay, let me give you a pictorial representation of this process. So Yarn application workflow in MapReduce. So as I said, resource manager. So there is a resource manager to which all the jobs are submitted. There is a cluster in which there are slave machines. On every slave machine there is a node manager running. Okay, resource manager has got two components. One is scheduler, another one is application manager. Okay, so Matthew says, what is the difference between application master and application manager? Application manager is a component of resource manager which ensures that every task is executed and an application master is created for it. Application master, on the other hand, is somebody who executes the task and requests for all the resources that are required to execute it. Okay. Now, let's say a job is submitted to the resource manager. As soon as the job is submitted, the scheduler schedules the job. Once the scheduler schedules the job to be executed, application manager will create a container in one of the data nodes. Now within this container, application master will be started. This application master will then register with the resource manager and request for a container to execute the task. Okay. Now, as soon as the container is allocated, application master will now connect with the node manager and request to launch the container. So as you can see, application master got allocated these two data nodes. Now this application master requested the node manager to launch these containers. Okay, as soon as the containers were launched, application master executed the task within the container and the result was sent back to the client. Okay, guys, were you able to understand this? Can you give me a quick confirmation on the chat window? Matthew says yes. What about rest of you? Good, thank you very much. Let's understand this in a little sequential manner. Okay, so on the right, as you can see, these are the lines. The first one is the client, the second one is the resource manager, third one is the node manager, and the fourth one is the application master. So let's see how are the steps executed between them. Okay, so very first step is client submits the job to the resource manager, as you can see right here. Now the second step is resource manager allocates a container to start the application master on the slave machines, right? The third step is application master registers with the resource manager, as you can see right here. As soon as it registers, it requests for the containers to execute the task. That is the fourth step. After that, application master notifies the node manager on which the container needs to be launched. Once the node manager has launched the containers, application master will execute the code within these containers. Finally, the client contacts the resource manager or the application master to monitor application status. Okay, and at the end, finally the application master unregisters itself from the resource manager and the result is given back to the client, right? So this is one simple sequential flow of how a MapReduce program is executed using Yarn framework. Guys, are you clear with this? If you want, I can repeat it for you. Matthew already said yes. What about others? Saurabh wants me to repeat. I'll quickly repeat Saurabh for you. The very first thing is client submits an application to resource manager, step 1. As soon as the client submits a job, the job is executed and resource manager will launch a container in step 2 on a slave machine, in which application master will be executed. Application master will then register itself to resource manager and say, okay, I'm ready. Can you please assign me a container in which I can execute the job? That is step 4. As soon as the container is assigned, application master will then connect with node manager on which the container needs to be launched. Node manager will launch the container and then application master will execute the job on that container itself in step 6. Finally, client will keep on checking the status of the job from the resource manager or the application master. Once the job is executed successfully, application master will deregister itself from the resource manager and the result is sent back to the client. So are you clear with this process, Saurav, now? And what about others? Everyone, are you clear? Saurav says perfect, thank you. Andrea, are you clear? Andrea says yep. Ashish says yes. Sam says very clear. It is the first time I guess Sam has spoken in the session. Great. I hope he liked it. So with this, we come to the end of this session today. Okay. So there are certain learning resources that you can go through. The Hadoop tutorial that I have already told you in previous sessions. So there is a MapReduce tutorial which you can go through, which is again very beneficial for you guys to enforce your learning. Along with that, you have a blog written on MapReduce interview questions. Guys, please go through this blog as well because it is going to give you the insight to the questions that are asked in an interview so that you can prepare yourself. Okay. So finally, we come to the end slide. Guys, if you have any queries that are left or any doubts that you have on the content that we went through, please tell me now. I'll give you a minute to do that. Okay, looks like everyone is very clear. Guys, I understand you're clear now. However, I will request you to go through the recording that is present in your LMS. This recording will be updated in your LMS. Please go through that so that if you have any doubts, you can get it clarified in the next session. Okay, I'll be more than happy to help you. You can also connect with the support team, Edureka support team. These guys will also be able to help you out with your queries. Okay, guys, before we end the session, I request you to give the feedback on the chat window itself. Matthew says, thanks Vineet for explaining the concepts clearly. I hope, Matthew, you were able to grab the concepts. In case you have any questions, let me know in the next session. Andrea says, thanks. Okay then, so it's time we end the session. As always, I'll repeat, please do your assignments before you come to the next class. They are present in your LMS. Take the help of the support team and we'll meet in the next session.
I hope you enjoyed listening to this video. Please be kind enough to like it and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!